Okay, now, what is differential equation? All right. So before this, you have learned about engineering mathematics. What have you learned in engineering mathematics? Okay, anyone? What have you learned in engineering mathematics before? Have you learned this differential equation? Can you hear me? I am disconnected just now.
Yes, okay.
Okay. All right. So in engineering maths, you have learned differentiation, integration, calculus, basics, right? Okay. You have learned polar coordinates. You have learned complex number. You have learned function, types of function, graph, limits, and so on. So those are the fundamental knowledge that we are going to use, okay, in differential equation. So let's say you have y equals to 2x cubed, okay? And then you differentiate, you will have dy dx equals to 6x squared. So this is what we call differential or derivative. So differential equation is any equation which contains derivative. Okay, any equation which contains derivative, either ordinary or partial. Okay, so this is differential equation. Right. So in this differential equation, we are going to learn basic definition. Of course, you need to know the basic definition, terminologies, and then type of the first order ODEs and methods of solution, and then application and so on. Okay, so in differential equation, there are two types of differential equation. Okay, first we call it as ordinary. Second, we call it as partial. In this ordinary, we have first order, we have second order, we have third order, and so on. And then this partial differential equation, ordinary differential equation, ODE, PDE. So all of these types, okay, all of these types should comply with the same basic. Okay, where you have to know what are the basic. Let's take a look. Let's take a look at the notes. Okay, so now you know, all of you know what is differential equation. It's just an equation which contains derivative or which contains differential. So there are two types, okay, like I mentioned, ordinary and partial. So now what is ordinary? Okay, in ordinary, It just contains one or more dependent variable with respect to one independent variable. Okay, so now you have to know what is the dependent variable, what is the independent variable. Okay, so what is independent and dependent? Right, so for this example, dy dx equals to 2x plus 3 d squared y dx squared plus 3 dy dx plus ay equals to 0. Y is the dependent variable. Why is the dependent? Because y depends on x. When x change, then y also change. So for this case, y is dependent and x is independent. As you can see, y is upside dependent, x is downside independent. Okay, so how can we know that this is ordinary? Okay, ordinary contains one or more dependent variables. What are the dependent variables? Y. So now it contains y. Here also y. Here also y. So one only. But it can be one or more dependent variables with respect to one independent variable. Only one independent variable. Okay. So for ordinary, it is only respect to one independent. As you can see, we have only x. Only x. Okay. But for dependent, it can be one or more. Right. What about partial? For partial, it involves one or more dependent variables. So this one is quite same with the ordinary. And two or more the independent variable. As you can see here, del squared u over del x squared plus del squared u over del y squared equals to 0. So u is dependent and x and y are independent. So as you can see, we have two independent variables. When it is two or more independent, then we call it as a partial differential equation. If you have only one independent, then it is ordinary. So that is the difference between ordinary differential equation and partial differential equation. And remember, in your chapter, we have the first chapter here, solving ordinary first order, ordinary linear order, and then Laplace, Fourier, partial differential equation. So you have to know both ordinary and partial differential equation. So for ordinary, for this chapter, we have, for this course, we have first chapter, first order differential equation. Second chapter, second order ordinary differential equation. Third chapter and fourth chapter is about the transformation. We have Laplace and Fourier. And fifth chapter is partial. Why we need to have these two first before we proceed with partial? Because in order to solve partial, we need to know how to transform first. Okay, so these are the summary for this course. All right, now you know the dependent and the independent variables. So what's next? Okay, can you follow me? Are you okay, guys?
Yes, doctor.
All right. What about this? We have u, we have x, we have t. Dependent variable only one, x and t. Independent, we have two. This one also u, x, and y. One dependent, two independent. So these three are all partial differential equation. Okay, now, can you determine whether which one is the dependent and which one is the independent variable? What about the first one here? What are the dependent and independent variables? Come on. I like to call some name. Who's the lucky one? Okay, now there's an answer. Okay, dependent X and T. Are you sure? Dependent X and T? No. Try again. Thank you. What is dependent variable? Dependent W, right? Dependent is W. Independent is X and T. So, considering to the number of variables here, is it ordinary or partial differential equation?
Partial differential equation.
All right, good. So, this is PD. Okay, what about this one? What is dependent variable here? Okay, dependent is U, right? Good. And then independent are K, X, and Y. So this is ODE or PDE? Partial PDE, okay? So now you can differentiate which one is ordinary, which one is partial, just looking at the number of independent variables. If you have only one independent variable, it is ordinary differential equation. If you have two or more, it is partial differential equation. Okay. About the order, as you can see, we have first order, second order. How can we identify the order of differential equation? All right. So in order to identify the order of differential equation, it is determined by the highest derivative, where, as you can see here, dy dx is the only derivative. So the highest derivative is dy dx, where it consists only one d here. Dy dx means differentiate y with respect to x about once. So only one. Yeah, this is first order. Okay, let's take a look at the second one. The order is determined by the highest derivative. So what is the highest derivative for this example? Dy dx or d squared y over dx squared?
D square y.
Okay, so d squared means you differentiate about twice. So this is the highest. So what is the value of those of the highest there? It is 2, means that it is second order. This is first order. What about the third one? You have to take a look at the highest derivative only. As you can see, what is the highest derivative for this? Is it dy dx or d cubed y over dx cubed? Dy dx mean, what is the meaning by dy dx? Dy dx mean you differentiate about once. This cube y means you differentiate about 3 times. So which one is the higher?
4.
No, not 4. This one. Right? You differentiate about thrice, 3 times. So the order is third order. You cannot choose 4. This is not the order. This is just the exponent of this derivative, where this derivative only differentiate once. Okay? It only differentiate once. Understand or not?
Yes, ma'am.
Yes.
Okay. So this is what we call order. The order is determined by here. This one is 1, so 1. This one is 2, so 2. Not here. This because this one is 1. So you have to take a look at the highest derivative. Okay, now that is order. What about the degree? The degree is the exponent of the highest derivative. So now first you have to take a look at the highest derivative, and then you have to take a look at the exponent or the power of the highest derivative. So from this example, what is the highest derivative? Here.
D square y dx square.
Okay, so this is the highest. So what is the exponent of this? This one is to the power of what?
1.
So first degree. Understand or not? This is, you know that from this example, you know that this is second order, right? From this equation, it is second order because of these two. And this d squared y over dx squared is to the power of 1, then it is first degree. Okay. What about this one? The highest derivative is what?
D cube y dx cube.
Okay, so this is the highest, and the degree or the exponent of this highest derivative is 1. So that's why it is 1. So as you can see from here, it is third degree, third order, first degree. Clear? Everyone's clear. What about the third one? What is the order for this example?
Second order.
Yes, this is second order. What about the degree?
Third degree.
Okay, good. All right. Okay, let's try this example. What are the order and the degree for each of these example? Okay, anyone want to try? First one.
First order,
First
second
order,
degree.
second degree.
Okay, first order, second degree. Right? Second one.
Second order,
Mm-hmm.
first degree.
Okay, good. The third one.
Second order.
Second order, first degree.
Second order, first degree. Okay, good. Next one, the last one.
Third order, fourth degree.
All right, excellent. Okay, so now you understand. Okay, so of course, in understanding this differential equation, you know that there is ordinary and partial, which determined by the number of dependent and independent. And then you know how can you identify the order and degree. Okay. And then linearity. Okay. Dependent variables and their derivative are of degree 1. Each coefficient of the derivative depends only on the independent variable. So this is how you identify the linearity of the differential equation. Okay, let's try this example. By looking at the definition of this linearity, the first one, you have d squared y dx squared plus 3 dy dx plus 9y equals to 0. First, you have to take a look that the dependent variables and their derivative are of degree 1. So the dependent variable here is y to the power of 1. And their derivative are of degree 1. So the derivative here to the power of 1, the derivative here to the power of 1. then fulfill the first condition of linearity. And then each coefficient of the derivative, coefficient here of the derivative depends only on the independent variable. Depends only on the independent variable. Means that this one, dy dx. So, fulfill. Then it is linear. Okay? Understand or not? First, check the dependent variable, which is y, and their derivative. Then check they are in a degree 1. And then check each coefficient depends only on the independent. Okay. Now, let's take a look at this second one. Why this is non-linear? As you can see, the derivative dy dx is not of degree 1. You know that the dependent variable is y to the power of 1, degree 1. But the derivative here is to the power of 4. So, this one is not fulfilled. Then it is non-linear. Understand or not?
And can you explain again?
This one, second one?
Yes, ma'am.
Sorry?
Yeah, I'm talking about the second one, the non-linear.
Okay. It is non-linear because the derivative is not of degree 1. Because the first item, in order to fulfill the criteria of the function to be linear, is you have to make sure that the dependent variable and their derivative are of degree 1. As you can see, this is the dependent variable, y, degree 1. This is their derivative, degree 1. But this one also their derivative to the power of 4, degree 4. So, it is not linear. Okay, you need to fulfill both here in order to make sure that it is linear. Okay, now let's take a look at the third one. Dependent variable and their derivative are of degree 1. Okay, y also to the power of 1. This one also to the power of 1. Right. But each coefficient of the derivative depends only on the independent variable. As you can see here, we have y as the coefficient of the derivative. We have x squared as the coefficient of the derivative, which means it is not depend only on the independent here. Then it is non-linear. Okay? Before this one is non-linear because of the degree is not 1. This one, because of each coefficient does not depend only on the independent. All right, okay, then the next one, why this one is non-linear? Dy dx equals to sine y. Does sine y equals to y? So here we have in terms of sine y. We cannot know the degree of y, right? Because
example 1 try பண்ண சொன்னா.
Sorry, are you talking to me?
Maybe he was talking with someone else.
Okay. This is not a linear equation because this one is not linear itself. As you can see, sine y is not a linear function. And then this one is quite identical with this, right?
Ma'am,
None.
why is the sine y non-linear again?
Because it is sine y. Sine y itself is a trigonometric, right? Am I right? Okay.
Doctor,
Yes.
what if the equation just now equal to sine x? Does it consider to be linear?
Sine x. Yes. Because that sine x is not the coefficient of the derivative. Okay. Remember, x is independent variable. It stands alone. Okay, so I believe all of you understand this. And what about the non-linear? Of course, other than linear differential equation, just like we did here. Okay, now you know the difference between order, degree, and linearity. So these are all important in order for you later on to solve the differential equation. You have to know the order, you have to know is it linear or not, and so on. Okay, then now the last one for the condition of differential equation, where you have to know their conditions, whether it is initial or boundary. We have two types of condition, initial and boundary. Initial will be given on a specific given amount, a given point. Boundary will be given on some points. Okay, as you can see, this is the example of initial condition where it use the specific given point. So use the specific given point, same point. X equals to 0, y x equals to 1. X equals to 0, y prime x equals to 2. But for boundary, given some points. So there are 2 points here. When x equals to 1, yx equals to 5. When x equals to 2, yx equals to 2. So these are the difference between initial and boundary. So by using this initial and boundary condition, will give you the types of differential equation, just like this one. So we have differential equation of what is the order here? Of
Second order.
second order. What is the degree?
First degree.
First degree. Is it linear or not?
Yes.
Linear differential equation. So you know that this is linear, this is second order, this is first order, and you are given the initial condition where x equals to 0, and you just can use y and y prime. Where can you obtain this y prime? How can you obtain this y and y prime? You need to solve this differential equation first in order to find what is your y. So this is the main purpose of this course. You know the differential equation, you are given the condition, and then you want to find the solution of the differential equation. Okay, by applying the condition. And the only difference between initial and boundary is just about the initial point. As you can see, 0, 0, 0, 1. For boundary, use the same function but with different initial point. That's it for the foundation and fundamental theory of this differential equation. Okay, clear? Clear, everyone? So basically, these are the picture of what you're going to learn for this semester. Right? Differential equation, there are two types. Ordinary and partial. So in ordinary, you have to know the first, second, third, and fourth. Okay, how can you know? You need to understand all of these terms first. Dependent, independent, order, degree, linearity, and condition. Which is done today. We have done with this part already. Okay, clear?
Yes, doctor.
All right, good. So after this, you're going to proceed with one by one the types of ordinary differential equation, and let's focus on first order first. As you can see, let me explain again the summary of this chapter. First, you have done with the basic definition and terminologies. Then you're going to proceed with the types of first order. So we're going to start with first order first here. Okay, so we're going to start with the first order first. There are many types in the first order, which is separable, homogeneous, exact, linear, Bernoulli. So we're going to go one by one of this type of differential equation and learn how to find and solve this type of equation. Okay, and then the application of first order. Okay, clear everyone? As you can see from the course information, once we have done with the first order, we proceed with linear second order where we are going to learn methods. There are variable types of methods in order to solve the differential equation of second order. After second order, we are going to solve up to fourth order here. Let's see. As I mentioned here, first, second, third, up to fourth order using the method given. Okay, and then how to transform, and the last one is how to find the solution of partial differential equation. All right, clear everyone? Anyone has question? Am I too fast?
Oh, doctor.
Okay, good. All good. All right, so I'm going to just use only 1 hour for today's lecture, just to explain briefly about the differential equation and the basic definition and terminologies of differential equation. Once you understand all of this, it's quite easy for you after this to proceed with finding the solution. As you can see, I have also give you the tutorial, right? Where, as you can see, the tutorial itself guide you to understand which one is ODE, which one is PDE, what are the orders, okay, indicate the independent and dependent variables. If it is ODE, indicate it is linear or non-linear. So we have done with these topics. Then you can start with doing the first tutorial up to 1A to 1G. Okay, and for the second one, it is the next topic. Okay, so anyone has question? It's easy, right?
So far, no question, doctor.
Okay. Oh. All right, if you have no question, don't forget to scan the attendance and you may leave the class. Thank you. That's all for today. Okay, see you in the next class. Can you scan this? Okay, good. Previous class cannot scan this. All right. Good luck for this semester and please bear with me for the whole semester. And I like to ask you to have more response after this, okay? It is quite such a lonely class if I am the only one who talk. All right, I'm going to stop.
Thank you, doctor.
Thank you, Rhoda.
Welcome.
Thank you, Doctor.